All right, so we're going to finish up what we didn't get done in class today. Looking at radian measure, finishing up some radian, and then looking at arc length. So a theta angle equaling 1 radian if S equals R, which we stated earlier. We had if S equals R, then that angle is measured. That's the definition of 1 radian. And if I look at that, my angle is equal to the arc length divided by the radius. So let me do this. So if the arc length equals the radius, I get a radian. 1 radian is the measure of that angle. But what do we do if the arc length is not equal to the radius? Well, we can just take whatever the arc length is and divide it by the radius, and that will tell us how many radians an angle is. So if I want to find theta, it is the arc length divided by the radius. That's how many radians that's going to be. So I take my arc length and divide by my radius. So I get, both of these are divisible by 2. That angle is 8/3 radians. And again, it doesn't have to have a pi in it for it to be a radian measure. It's a radian measure is the arc length divided by the radius. How many radii, or how many times will the radius lay down on that arc? In this case, it is 8/3, which is 2 2/3. What if we knew the arc length was 25 and the radius was 30? Go ahead and try and find that angle. Pause your video. So again, we're going to take the angle equals the arc length divided by the radius. So I have an arc length of 25 and a radius of 30. When I reduce that fraction, both are divisible by 5. I get 5/6 radians. So if I know the arc length and I know the length of the radius, I can find how many radians that central angle would be that is subtended by that arc length. So what is arc length? Well, since we know that theta is equal to the arc length divided by the radius, for theta in radians, that is the definition of a radian measure. So if I take this and solve for the arc length, solve for S, multiply both sides by R, I can see that the arc length is equal to the radius times the angle in radians. That is very important. The angle is in, like that. The angle is in radians. This is only true if it's in radians. So again, we looked at this a little bit, but if I do one full, the arc length, if I do one full rotation, that means the entire length around the circle, the angle that I'm going to rotate through in radians is 2 pi. That is my theta. And then the radius is whatever the radius of that circle is. So the arc length for one complete rotation is actually the circumference. And so it should make sense. We looked at it a little bit earlier, but where that circumference of a circle formula comes from. Okay. So what is arc length? if I know that the angle is 2, and this angle is in radians. And why would I know that this angle is in radians? Well, I know that it is in radians because there is no degree symbol. So if I told you this was 2 degrees, I would have to have a degree symbol for that. If we do not have a degree symbol, we know that the angle measure is in radians. So the angle is 2 radians and the radius is 5 millimeters. So my arc length is going to be the radius times the angle in radians. So that's going to be 5 is the radius, and my angle measure is 2 radians, which gets me 10 millimeters is the arc length. What if theta is 1.2? Again, that is in radians because it does not have a degree symbol. And the radius is 4 inches. Go ahead and try to find the arc length. Pause the video, see if you can figure out the arc length from this. So I know the arc length is equal to the radius times the angle in radians. So my radius is 4 inches. My angle is 1.2 radians, which means this arc length is 4.8 inches. Okay, and now let's think about this a little differently. What is the radius if? Okay, so if you understand this arc length, I want you to try to figure this one out. If the angle is 2.3 radians and the arc length is 52 meters. So I would like for you to pause the video and see if you can figure out what the radius is for this arc length. So if the arc length is equal to the radius times the angle, I know the arc length is 52 meters and the angle is 2.3 radians and the radius is unknown. I can just solve that for the radius. So I'm going to divide both sides by 2.3. And please do not leave this as 2.3 and 52. We do not want fractions in fractions, and a decimal is just another representation of a fraction. So you're going to multiply the numerator and the denominator by 10 to move the decimal place. So I'm going to get 520 over 23, which cannot be reduced. So this is in meters. Hopefully you got that right. Okay, there we go.